Great. Hey, everybody. Thanks again for joining. We are here for the first session of the Learn-to-Earn portion of Mina Navigators. But again, this isn't related only to Mina Navigators. If you don't have a badge yet and you're waiting to kind of get your badge at the next time, that's great. This is really about anyone who wants to learn about o1js and developing on top of Mina and really getting into the weeds over the next 6 months with the development mindset, o1js, thinking about off-chain computation, recursion, things like that. So this is a great opportunity. We have a very experienced professor here, Professor Lawrence, who's joining us. Lawrence also runs the ZK bootcamp, or teaches the ZK bootcamp as part of Encode Club, and also has a consultancy related to Web3 and blockchain. And many of you on the call have taken courses from Lawrence as part of Encode before. And so since it was working so well, we decided to ask Lawrence to also help educate our Navigator group as we are getting up to speed and building ZK apps. I think just to cover the really, I think Lawrence may cover this as well, but I'll just cover this really quickly. The Learn to Earn part of Navigators is really an addition to the structure that we have for the monthly grants. So we have you can see here that we have o1js review, we have development workflow, recursion, application storage solutions, decentralization, ZK oracles, ensuring security, and then a review session at the end. This page is publicly available on Notion, so maybe I'll just drop the curriculum here in the chat. And what we're going to do each month is have one session that's related to a topic, and then after that we'll release a challenge with a actual application of that topic. So we'll ask you to take what you've learned and build something in relation to that. We're releasing the challenge on Tuesday of next week. We also have a meeting scheduled for Tuesday where we're going to actually talk about the update to the Mina Navigators program. For December, it's going to be the same. So it's going to be 10 days of commits, of meaningful commits that our team will check. But at the end of December, we're going to ask you, if you're building with Navigators, to submit your the work that's been completed so far, not just the repos, but we'll also ask you to submit a form that actually explains the work. And if you're on a team, asks for your contributions versus your teammates, and also lays out the development and milestones that you want to complete for January. We're going to shift to a month-by-month milestone kind of program, just so that there's a push towards building finished products or finished libraries or things that are pushing forward. So it's not just only working on commits. But on Tuesday, we're going to talk about this, and that's when we'll also release the program details. So today, we really want to spend the time just covering the o1js basics. Lawrence has shared the first kind of like document PDF in the Navigators chat, but that's what we'll be working through today. And then stay tuned on Tuesday for updates to the actual like program rules and structure for January onwards. The one thing I'll say is, because we're kicking off the challenge next week, the first challenge won't be due till the end of January, so we have a bit of time to work on it. We understand there's a lot of different things, and especially if you're in tune with other Mina programs as well, there's lots going on. So and it's the end of the year. So the most important thing today is to pay attention, ask good questions, be engaged, and be respectful of the process. And yes, we'll make the recordings available afterwards as well. So we've got this recording. We'll make sure it gets uploaded to our YouTube. And yeah, today again, like is the first step. So I would say the best thing that you can do is be present, be engaging, ask questions if you're not sure about things, and we'll go from there. And we're building this a bit on the go, as if you're part of our programs, we do a lot of these things as we go. And so I just want to say, before we get into it, a huge thanks to Lawrence for devoting his time, his team's time to working with us here. I'm really excited about the potential of inserting a direct learning element into our programs the way that we have here. And yeah, we'll see how it goes. So with that, Lawrence, I'll turn it over to you to get started. We have the next 83 minutes left, and I'll leave it to you how you want to use that time.
Great, thanks, Will. Hey everyone, GM, Good to see you all. It's nice to see some familiar faces, but also good to see new ones as well. Let me share my screen and then we can make a start. Does that work? Yes, that's working. Okay, good. All right. Okay, so I'm going to, I think that you can see that okay. Yeah, I think you can see that okay. So, yeah, so welcome to session one. I'll just start talking about the format a little bit. I mean, really, I think Will's covered a lot of this anyway, but yeah, so each session will be 90 minutes, and then we have the challenges as well. The first one you'll get on Tuesday, and it's something to keep you occupied over the holidays. And then, yeah, the rest of the sessions, this is the list. I think that's also on Notion. I think I've got the dates correct here. If these are different, then the Notion ones are correct. So please look at those. But I think these are correct for the upcoming sessions. One thing to say as well, though, I want to cover these topics. I think they're all going to be interesting. They're all going to be good for you to learn about. But also, we want to be quite flexible in this program because it's very much about giving you experience and exposure to different areas that are going to be useful to you when you are building. So what we've done is we've created a poll on Slido. Now let me just give you the link to that. There is a link in the notes as well, but I'll just give you, I'll just pop that into Zoom chat if I can find my Zoom chat. Oh, yes, there we go. So so there's a link to Slido, and there's two parts to that. Let me just show you that. So one part here, as you see the tab, it says Q&A, so that you can put questions in there, and I'll try and get answers to those. There's also the polls part here, where it's your chance to add in any topics that you are particularly interested in, and we'll try to be flexible about that. We should be able to fit those in and really sort of tailor this to make it so it's going to be the best to help you build in the program. I should also say thank you at this point to my colleague Meek, who is here, who will also is also helping out. So yeah, I want to say that. Yes, so that's Slido. So please do. Oh yes, put the questions in. Make sure you get the correct tab for that. What I will do as well after each session, or maybe I'll give it a couple of days, but I'll get all of the questions and the answers collated together, and then I'll put those into a document and put that onto Discord. So you've then got a record of all the questions and answers as well. So that should be useful. Okay, so that's the Slido. So that's covered that. Yeah, there's the link in the notes. The notes, yes, if you haven't seen the notes, there's a link to them on, yeah, I put them on Discord, uploaded them on Discord, so you should be able to have those. And what I will do, I'll try to give you a little bit of, I'll try to present them a little bit in advance for each session. So I'll try to get them to you a little bit early so that you have a chance to read through them before the session. And you'll have, I think it's easier to get engaged then and to think of questions if you've done that. All right, so just a little bit about XP. We've been working with Mina since about 2019. I had a look through my emails and I found going back to about 2019, when we first sort of got involved with Mina. We very much love Mina, so it's been a great time. We have been doing obviously we do teaching about Mina as well, but also we do we've done a meetup last year in London. So this is a photo from that. As you can see, there's members of the Mina team there and some members of from XP as well. I'm hoping that we'll be able to do some more in-person meetups as well. I guess people have moved online rather than in person, over the last few years, but hopefully we'll be able to get some more range. And also we do tend to travel a lot, and I know the Mina team travel a lot to conferences, etc. So if you go, if there's a conference in your part of the world and we're there, please do come say hello. It's always nice to get to see people in real life rather than just over Google Meet. Okay. So yeah, so I can see someone's already got to the poll. Okay. Okay. All right. So yeah, please just add the questions, or sorry, add the topics into the poll, and then we'll devote time to those in future sessions. Okay, so what I'm hoping to get through today, these are the topics I want to go through. Today's session, it is a little bit general. Part of that is because, as I say, I want to make the sessions quite customized, quite flexible, so that you can choose the topics that you are particularly interested in, or that maybe you have if there's something you find confusing, or want a little bit more experience with. So this first session is going to be something of an introduction, and I'm going to start off very general, I suppose, by talking about decentralization, but that's really at the heart of everything that we're doing, and I think it's worth stressing that and worth thinking about that. I'll also have a look at the roadmap for Mina as well, because it's useful to know what things are coming up and what technology we can expect. And certainly when you're building, it's useful to know what's going to be available there. We'll have a look then at some at o1js a bit, looking at the data types. I think these are ones that you probably you may already know about, but it's worthwhile just having some links, etc., and just going through some of those. We'll also look at permissions. Obviously, this is important when you're thinking about security. Bitwise operations is a topic you may not have needed to do. You may not have come across it yet, so it's worthwhile just having a quick look at that. We'll look at composability as well. So it's quite a fundamental feature of DeFi, and so we'll look and see how you can do that within your programs, and then we'll finish off looking at a topic, the action reducer, which is quite a large topic really, and there's quite a lot to consider with that. And as you'll see in the notes, I've got some discussions about that, because it's not as straightforward as you may have thought initially. Okay. All right. So sorry, let me just quickly go back to the chat. Okay. All right. Yeah. So yeah, some previous XRP employees there. Yeah. Okay. So I would start with decentralization, and I make no apology for this, because it's something that's easy to lose sight of when you're developing on blockchains. Whatever blockchain you're using, it's often easy to forget that this is really the main reason we're using blockchains rather than a database. The idea of having decentralized systems. So I want to just talk about why we're doing this and the motivation behind this. And I think this applies particularly to Mina. I think this is one of the great strengths that we have with Mina, in that it manages, because of its the way it is structured, it really manages to be decentralized. And I think it's resisting the pressures of centralization that other blockchains are struggling with. So I think, yeah, it's important to think about why we're doing this. So as a bit of background, centralized systems have problems, and this may well be the reason that people got into blockchain initially. This it really was for me, actually. Actually, the final point here, the control of money for political reasons and WikiLeaks, that's when I first found out about Bitcoin, and that got me interested in blockchain. And yeah, I really haven't looked back. But yeah, I'm sure you're familiar with some of the kind of problems that we get with banks, for example. The fact that you can get bank runs, like banks can close, they don't have enough reserves. We have crises, and if you have your savings in a bank, obviously this is a major crisis for you. It's going to be a big problem. Also, things like the availability as well. I still find it slightly strange that if I can't do certain things at a weekend or in the middle of the night or something, when I'm used to being able to, use blockchains whenever I want. Also, the idea of the money supply and all that control by a central authority that we don't have with blockchains, and then the idea of control as well, and that's there's censorship, etc. And the way that these systems are built, the centralized systems are built, is that they try to keep out the people that I don't want by having sort of layers and layers of security around their system. So they try to restrict the access to their system for security reasons, well, amongst others, I guess. But the way that decentralized systems work, or particularly public blockchains, is quite different in that they, for a public blockchain, it's an open system. People can not just use don't just use the system, but they can join in and participate and be part of the whole ecosystem, really, and part of the community for that. But the way that you get the security then is to build your system and build incentives into your system to ensure that people are incentivized to behave in a certain way, and that will hopefully keep your blockchain running in the direction that you want. And so the good things we get then from decentralization are things like the fact that you get greater participation, and there'll be more diversity of the people involved and the types of things that they're trying to do. And the fact that the conflict resolution here really is the fact that we have consensus mechanisms that allow us to come to agreement, even though we've got this big decentralized system and lots of different people being involved. But the major one, certainly for me, I think, is the idea of moving power to the edge. So the idea is that, with a blockchain, that I'm the one who has control over the assets that I have on the blockchain, or maybe my data as well. And that for me is a very important thing, and one of the great advantages. Okay. Now, that's the ideal. Now, it can become a little bit problematic, because if I take the instance of Ethereum, as Ethereum has grown over the years, the state that is involved has increased quite a lot. Now, back in the early days of Ethereum, it was possible for people to run a node quite easily, but it quickly demanded more and more resources, better and better hardware to do that. And the problem with this, if you design your blockchain with certain hardware requirements, if those hardware requirements increase over time, that means that a particular node may then start to not be fast enough or not have enough storage. And so what will happen is it will start to fall behind the rest of the network. It won't be able to process the transactions quickly enough. And so it will lose consensus with the network and effectively fall off the network, which will overall mean that fewer people are involved, fewer people are running nodes. And so that is then a pressure for centralization. And that's one of the great things about Mina, is that because of the very clever design with Mina, the fact that it is a synced blockchain, we have this ability to keep participation and to increase participation and get lots of people involved with very low resources. And as you can see here, I took this quote from the roadmap and one of the tracks from that. But this idea, I think, is a wonderful idea. The thought you could be participating, on a very everyday device, and that because of what you're doing, that's securing the whole network and securing. It's not just for helping to secure your transactions and your assets, but that contributes to the whole system as well. And you could, we can end up with a really large amount of participation because we have this succinctness in Mina. So I think particularly, why I've started off with this is that, as I say, I think it's important when we're building to keep this in mind. I know it's easy to lose sight of this and to very much focus on a sort of particular type of application and the sort of applications that you see in blockchain. But I think at the back of your mind, you should be remembering that we are all about decentralization, and particularly with Mina, this does provide a lot of opportunities. And I think, as builders, it's great if we can make the most of those and really make the most of what Mina is providing. And as an example for that, there's the web node. There's a link to the blog post there. The idea that you can run a node within your browser, and you can try that out, and you can certainly do that. And I know I've seen other systems or other blockchains say that this is what they would like, and I'm sure they're honest about that. But I think this was the first time I really saw it actually happening, and actually realized that I had an actual node within my browser, which I think is very valuable. Okay, so that brings me onto the Mina roadmap. So I'm hoping this is going to work. So I think it's just useful to have a look at a few of these. And I'm sorry, I'm going to have a difficulty then finding the bits, but it's a useful diagram because it's showing you where we are. So here, we're looking at the idea of a node in the browser. This is all around the cluster minimization, but you can see the other things that are up and coming as well. We've got things about our programs as well, and getting those onto mainnet. We've got things about performance, the Miniverse, which I'll come on to as well, and deification. So lots of useful things there. It's worth having a look at that and looking at particularly just getting an idea of where we are and what's the kind of things that are coming up as well. I'll come back to the ZK rollups in a second and just talk quickly about the Miniverse, because again, this is something I think is a great opportunity that you have with blockchains, and it's something that I felt was a little bit exactly wasted, but didn't come to fruition as much as I was expecting, or as soon as I was expecting. I know years ago I saw people, excuse me, having the idea of interoperability and of linking blockchains together, and I always was thinking, okay, well, this is the year where this is all going to happen, and everything is going to get linked together, and it didn't really happen. And I think this is when it does happen, and things like the Miniverse is going to help with that. When this does happen, this is going to open up a lot of areas as well, and just things that I think one of the standard things that people say about this is the idea that we can things like liquidity, the fact that we can get a view of liquidity and do that across multiple chains, and also, as you see here, the idea of using the security that Mina has, and then easily building new systems with that. And it's one of the directions that we see generally with blockchains is around the idea of if you sort of follow the Ethereum ecosystem, you'll still see the layer 2s and the idea of layer 3s, where people are building those. And we've got this idea of app chains. People are starting to think of things like that and getting very specific chains being built, specific to maybe an application or a type of application. And I think Mina has a lot to offer there in the idea of being able to build those, but having the security that Mina provides because of the ZK aspect. Now, I want to talk just a little bit then about the ZK rollups, and I did look at the and please do correct me if I'm if this is no longer. I see it hasn't been updated recently, so I don't know if this project is sort of what stage it's at, whether people are looking at other things. But I have seen discussion about this idea, and it's slightly. It struck me when I first had the idea of sort of ZK rollups. This struck me as slightly odd because rollups is very much a feature of Ethereum. Their roadmap is rollup centric. That's how they're going to scale, and it's working well for them, I think. But one thing that Mina has kind of already solved that partly with the idea of well, with a rollup, you part of it is you're taking execution off the layer one, and to reduce the load on the layer one, and sort of Mina already kind of has part of this because we have the idea of computation being done off chain, and so they've already sort of made a start on that. But I think the where we could see this taken further is the idea of what rollups do is the rollup sort of name gives it away, I suppose, the idea of batching things as well. And so we still, even when we're doing computation off chain, we still are sending updates on chain. Obviously, we're still sending transactions, and so things that could optimize that process could then be also useful. And Mina also has a bit of a head start anyway because of all of the support for on the ZK side. So yeah, so that's I think that's an advantage also. So I just wanted to mention that because that could be quite interesting. But it was perhaps slightly different. Now another project I wanted to just mention. Now, where have I lost? I've got lots of tabs here. Yeah, I wanted just to quickly mention this project as well that was in the blog because I quite like it because it's very easy when you're people are building projects. People often focus on financial DeFi, that kind of thing. I'm always pleased when I see things to do with privacy. I think because that that was one of the reasons I really liked the idea of blockchains, and particularly zero-knowledge proofs initially. So I'm always pleased to see those. And so I just wanted to show you this because you can have a read. It's in the o1 Labs blog, and it just shows how they built a solution, or they built a project, and quite easily as well. As you can see here, they've just got some they've got some fundamental, just some some pieces of code that's sort of at the heart of it. But it's not a I don't think there was a lot they had to do. I think it was something that quite easily fitted into the way that we develop on Mina. And yes, I just wanted to show you that the idea. This is the architecture. The idea behind it is that as we're trying to move away from cookies, it's a way to sort of establish your details and but do that and control that by using zero knowledge. So it's an interesting project there. And as it says here, they did a lot of it was sort of already available just because of the way of what is already available in Mina. So yeah. So just wanted to mention that to you and give you a link to that. Okay. All right. So another resource that is worth having a look at is the updates. Sorry, let me just. Oh, sorry. Oh, I've lost. Is the updates from the blog. So I just wanted to mention some of those. So I just want to close some tabs. So this. Let me check that link. Yes, so this you can see I think every month they try to publish what's new. So it's worthwhile having a look at that, because it may well be, as they they make changes to o1js, it could well solve any, if you're stuck on a particular thing, maybe there's something that's not working well in the sort of the way you're doing it. Maybe there'll be something in the update that will help you. So just to go through a couple of things from that, a couple of things that have happened recently. So there's the first one here about the proof of key caching, which is just an optimization. I say just, obviously there's a lot of work involved in it, but it's all about optimization. And where this fits in, if you remember the way that these things, the zero knowledge proofs work, is the idea that we from our setup, we have a prover key and a verification key, and the prover key is needed when we're creating the proof. And so by caching that, then we can create our proofs more quickly. So yeah, that's what that's about. And then the second one is a little bit more involved. I'll just talk a little bit about that to explain what that is about. So the way that circuits work in zero knowledge proving systems, or what happens basically is and I'm talking generally now, but the code that you write will go to create a circuit, and that circuit, an arithmetic circuit, is built of a number of gates, and the default gates you have are arithmetic, addition or multiplication gates, and those are kind of the most basic type of gates. And within those gates, there will have maybe 2 inputs and 1 output, and then you could, from that, just from those basic 2 gates, you can really build anything. You can describe any polynomial. You can, I think, sort of effectively describe any computation. But it's not necessarily the most efficient way of doing that. And so what if we have custom gates? What they do is to allow us to create things that are going to be useful for perhaps particular parts of some algorithm, and or make build gates that are just more efficient for what we're trying to do. So it may be that we have a gate that has 3 inputs rather than 2, something like that. And yeah, things like that help really for you to optimize your circuit and to make it so that it reduces the amount of resources in terms of the number of gates you need for a particular task that you're trying to do. And I'll come on to, I've got some details a little bit further down about some of the general the restrictions we have with our circuits. Excuse me. The second part there, the lookup tables, this again is a something to optimize the way that we produce proofs and produce our circuits. And that again, you could do everything with additional multiplication gates, very generic gates, but it's not necessarily very efficient. And so what lookup tables do is to say, well, there may be some operations that we can actually work out beforehand, and we can kind of hard code some results from some operations into a table. And then rather than having to get these additional multiplication gates to produce that result themselves, we can just go to one of these tables and look up the result. And this is used, particularly things like bitwise operations work well with lookup tables, or work better with lookup tables. And also if you're doing a range proof, if you're trying to show that a value is within a particular range, if the range is small, then a good way to do it is just to build a table with all of the values within that range in the table, and then just within your circuit make it get the value you're testing, and then see if that is within this this little table that you've built, rather than trying to do some kind of algebraic means of checking the range. So both of those things are going to help us and mean that we can get more out of our circuits. Okay. So the question is, ZK app chain like a roll up on top of Mina? Yeah, so that's the general idea of a roll up, is that you would have a layer one, which is has the security and also the settlement. Well, there are different concerns you have with blockchains, and which you can think that the layer one may be providing security, it may be providing settlement, it may be providing data availability, and then you could perhaps build other chains that will link to that to do other things. And I think the general direction we're going in blockchains is they're kind of breaking out a little bit and becoming much more specialized. So yeah, that's the kind of thing you would see. So maybe a ZK app chain would then be specialized and optimized to do a particular application very efficiently. But then it would come back to the layer one, come back to Mina for assets or for security, things like that. Yeah. Okay. All right. Let me just check other questions. So, okay. So the topics, yeah. So these look good. I certainly would be happy to do those. The idea of some live builds, yeah, that's good. Existing projects, certainly I'll be happy to go through some, and we can go through sort of deep dive into some code as well for that. I think that would be, I think that would be very very valuable. Okay, cool. Okay. All right, so just go on to some questions about programming for ZK systems, and things just again to be aware of. If you're new to building on a ZK system, if you've come from, you've been building on Web 2 maybe, and then you come to build on something like Mina, it's often a bit of a shock, because things are much more difficult than you found previously. So just to give you some ideas why that is, and perhaps a little bit of hope as well about the direction we're going in. So I don't want you to despair about this. So first of all, it is a relatively new area. You'll, by developing on using zero knowledge proof systems, this is really the cutting edge that you're working with. So that's something good also. But obviously that means there's lots of innovation, lots of change all the time. The performance is maybe worse than you've experienced on centralized systems or on Web 2 languages, and particularly with ZK, because you have this additional sort of process of creating proofs and verifying proofs, and all of that will take time. But again, this is something that people are working on and improving all the time. They're getting the times for these. They're reducing the times needed for this. Now, one thing that you will find, and again, this is not just on Mina here, this is true for really any sort of ZK system that you work with, is that you will find that the zero knowledge part and the cryptography that is needed for zero knowledge does intrude into the language to some extent. It does have an impact, and this is because we work with finite fields rather than with, say, the real numbers, and so doing that does have an impact, and you have to be aware of that and have to realize how finite fields work, and the things like mod arithmetic, those kind of things. And then also there are performance problems and limitations on the circuits that are created from our code, and again, this is something true for all zero knowledge systems, because these in order to take some code and to build that into something that can be proven, it does require something quite complex. And so, even a what might seem very simple could require a circuit, of many gates. And in order for this to be, in order for the system to work, we have to put limitations on the circuits. And so we have that in o1js as well, and I think this is still true. Some of the restrictions that you can do, and so you can see that doing additions and multiplications, we can do quite a lot of those. So that means we could have quite a lot of gates to do those for us. But what is often a bottleneck in ZK systems are hash functions, because they are quite complex. And even though we use specialized hash functions in zero-knowledge systems, ones that are more ZK friendly than some of the previous ones, they still can be quite a bottleneck. So you do have to be aware of that. And one of the areas this might impact you particularly is when you're using things like Merkle trees, because with a Merkle tree, you're doing this involves a number of this involves quite a lot of hashing going on to build the tree and to get to the root. And so obviously, as the larger your tree, the more hashes will be needed. And so that can be a bottleneck also. But one of the great things about Mina is it's all about recursion, and it's so one way to get around this is, if you're coming up against these constraints or these limitations, is to break your program down into parts that will produce proofs themselves, and then you can recurse those proofs together. And we'll talk about recursion in a later session. That the whole area of recursion in zero knowledge has become very well, not just popular, but there's a lot going on at the moment in around recursion in zero knowledge proofs. And I was also very impressed with Mina in that they seemed, they seem to be one of the first systems that were using recursion in a useful way, and it always felt that the other systems were ignoring it a bit. But I think more recently the other CK systems have caught up somewhat. But anyway, it's an area that there's a lot going on. There's a lot of innovation in that area, but it's a very useful technique. That's why, to be able to put together two proofs and to create a proof that both of those are correct is something that is very useful, and something that we can use as well, and we'll go into that. Okay, and I've put this link and I've completely forgotten why I had this. Okay, yes, so this there's a good, so this is the fact, the o1js fact, and I thought there was a very interesting this question here, I think, is, if you haven't looked at this, I think it's I think it's useful to go through this. It's going to give you good insight, because it is a lot of other ZK systems, they'll talk about compiling their code into a circuit. With o1js, it's a little bit different. I suppose maybe you can think of it more as sort of assembling circuits from what is in your code. So that's kind of the first point as well. And then if you read through this, it shows you some of the implications about this. And what is useful to remember when you're building is that part of the things you use are going to be used for your proof. And this is why we're using very specialized libraries for that. But we also can, you can also include JavaScript as well. But you have to be aware that that is not then part of the proof. So the part that you need to prove obviously needs to be built with elements that are provable. And these are the specialized things, and these will be data types or methods that you probably haven't come across before you started to look at o1js. But that doesn't mean you can't use other things. It's just that, as it says here, you've got non-circuit code that doesn't then become part of your circuit. And there's a couple of examples here that are interesting to have a look at and to work through and to think about, because it sort of shows the difference there. I like the just to look at Slido. Yeah, thank you, Ilya. Yeah, I really agree. Understand recursion. It is mind blowing, and well worth it. All right. So that brings me on to another topic that again is quite general, but it's worth remembering as well, that we are thinking about creating proofs, and so you have to make sure that that proof is proving what you want it to prove, and that everything that we have within our code that needs to be checked, is going to be checked. If we're making some kind of claim within our program, then we really need to test that very thoroughly. And it has been very easy. It's easy to have what's called under constraint code, in the sense that you will have something that gets turned into a proof, but that proof isn't quite as complete as you might think. And so this just, again, something to bear in mind when you're writing your program. Just bear in mind, just think about that you've got enough checks in there to make sure you really nail down everything that you need in your proof. Okay. So let me go on. Okay, so some basics, and again, I'm sure you've gone through some of this, so really this is probably just going to be useful for you to have some links there. Let me just close down some of these tabs. Yeah, there's some useful links. So there's links there to the Mina documentation, and I will say the Mina documentation has improved a lot over the last year or so. So thank you very much for that. It has improved a great deal. There's some really good tutorials there and explanation of concepts, and I've a lot of the notes I've taken from that documentation. And now I also want to mention the Mina playground. This came out of a this came out of one of the earlier builder programs. I'm sorry, I've forgotten which one. And I don't know if maybe my internet's a little slow. It's taking its time, but it is a very nice, a very intuitive environment to use with Mina. I don't know if people are using this or other things. I think in our next session, actually, we'll talk more about development generally and look at different tools and things like that. But I just wanted to mention it. I do like it. It's got some useful tutorials. So you can see here, it's got examples of tutorials to do, some useful things, similar to what I'm going to talk about today, actually, common methods and functions. This is the this sort of just the o1js part, just on that side, and then you also have it talking about contracts as well. So it's using that then within those language structures within contracts, and is showing you all about how to do that. So a really nice resource there. And actually, one thing I wanted, what was it? Interestingly, this is not part of the challenge, but I would be interested to see what other people find with this, that is this code. So please try this out and let me know if it works properly for you, and if not, then why not? So there's a mini challenge for you to look at over the next couple of days. Okay, so that's Mina Playground. Yeah, it's well worth trying out if you haven't looked at it already. Let me just quickly look back at yeah, thank you. Okay, so let's just quickly go through some data types. I think this is probably things that you already know. So really, it's just going to be more useful having the links available here, I suppose. So we've got some basic ones. Obviously, you're going to choose these depending on how they are going to be used. So if it's numeric, then you can choose that depending on whether it's going to be signed or unsigned, and the size of the data or the size of the number that you want as well. So that, I think that's all straightforward. We have more advanced types. So as you can see here, so for example, with the circuit string, we can create strings from a string literal. Obviously, we need key pairs. Because we're going to be signing for things, we need addresses, etc. So we have these data types available to us. We can create a private key, as you can see there, because a private key really is just randomness. So you get that, and then once you have a private key, from that you can derive a public key. So that's all very standard, I think. And then once you have some keys, then you can use those to sign messages. And so there's this a signature data type as well, which allows you to sign a message and sign it. You can sign it with your private key, and then having done that, you can send that digital signature to someone, and they can check the signature against the message and the public key. So you're not giving away your private key, but you can check it against the public key. And there's an example here. I took this again from the documentation, just reduced it in size a little bit just to sort of bring in the relevant parts. So here we've got a number, and we've set up a public and private key pair. We've created some data, and then we've from that we sign it by creating a signature using the private key and the data that we want to sign the message, and then later on, when we can verify that by calling verify and using the public key and the message, and then that will verify the signature. So quite straightforward. Yeah. Okay, let me come on to some other data structures. And I mean, Merkle trees are just so ubiquitous in blockchain. They're used everywhere, and they're very useful because they allow us to put a large amount of data into a structure and then get a very compact representation of that by you're taking the Merkle root, that is like a fingerprint of all of the data within our data structure. And if there's a change to the data, then that would give us a different Merkle root, a different fingerprint. And people use these often when they want to store large amounts of data, and where there are limitations on doing that, say on chain, whether that's because that we are limited to the amount we can store on chain in Mina, or whether it's just the fact that it's going to be expensive. A Merkle tree is a way to have a large amount of data and then get a fingerprint of it. And it's a very well understood data structure as well. And so there's support for that, as you can see. The link there to the details of that. So you import the Merkle tree type, and you can create one for a particular height. And so these are binary trees, and so if you specify the number or the height of the tree, the number of levels within the tree, then you get a certain amount of leaves of the data elements. So for a particular height h, you will get 2 to the h-1 leaves. So that's the way you can work out what the size is, and it's a very common pattern to store some data in a Merkle tree, and then store the root of that on chain, and have that as a fingerprint, and to show, to sort of, well, more than timestamp it, but to have a record of that, a sort of summary of that data at a particular time. We'll come on to later on in later sessions. We'll go through and talk more about storage solutions. So it's not something I want to go into details now. I just wanted to mention the data structure itself. And when you're dealing with Merkle trees, if you're talking about a particular leaf, then you need in order to get to that, it needs to have a particular path through the tree. The way that we can specify that with a standard Merkle tree is we can specify the index of the leaf. And so here's some example code where we're okay. So this is the did I get the contract separately? Oh, yes, I did. So this is the contract where we've set up. We're storing at the tree root as part of our state, and then to interact with that, we're creating a tree of a certain height. As you can see here, we're creating some value that we want for that, and incrementing that, and doing this locally. So this is our Merkle tree. We're doing this locally, obviously. Then we can update the contract with the details of that via a transaction, as you can see here. And that's that. And then you can check that that has worked, and that the roots are the same. And then within your contract, you have the tree root as being part of your state. So you're storing that, and then that, obviously, when you change one of the leaves in your tree, that's going to change the root. So you get an update to update that. And these are checks here to show that all of that has been done correctly. Okay. Now, a similar data structure is the Merkle map, but in that you, rather than having an index to a leaf, you have a key for that. So that's quite useful. So you can refer to things by keys, because that's probably what you're going to, the way your program's going to work generally. You're going to be thinking of things in terms of their function. So that, there's just a little bit of whoops. Oh no. Sorry, I'm going to scroll back through this now. So there's just an example of that. Sorry. Okay. How are we doing for time? Okay, I've got a bit of time. I'll go through this fairly quickly, this next part. It's really just telling you things that, just sort of showing you the details. But just obviously, you need to be careful when you're building applications. They need to be secure. You need to be sure that they're going to be used correctly, that there is sufficient authorization within your application. And so for that, we have permissions, and these we're going to get checked when we have when we're trying to do an account update to try to change the state. Just in terms of just the terminology as well. So the permissions are about who can execute an action, and then the authorization is about what that can actually, which resources that can affect. Now, the permissions apply to accounts, and so there's links here. Yeah, you can change these to be relevant. Obviously, you're probably going to want to make it. I mean, the approach I take with security generally is to try to make things as restrictive as possible, first of all, and then begrudgingly add back permissions as time goes on, as the functionality needs it. And that way, that gives me a little bit more reassurance that I'm not going to have opened up things, to the world that to allow them to do things they shouldn't do. Yeah, that's the approach I would say. But you have anyway, these are the permissions that you get on an account. So very much about what account can do. So the fact that it can send Mina to another account, that you can delegate if you're for staking, etc. And then we have methods to set these permissions, etc. And the other keys. And if there are tokens involved, that could be used there. And then obviously some of this is going to be, some of this happens sort of behind the scenes, I guess. Things like incrementing the nonce. Okay. We'll come back. So there's a link here to the custom tokens. I think I'll probably come back to that in a later lesson, and also around, specifically around time locked accounts. We'll if people are interested, we can go through that, and I can find you some examples of that and give you some details there. So those are permissions, authorizations. These are you have different possibilities. So you can have things, you can use proofs and signatures with authorization. So which I think kind of makes sense. We have, signatures would be the default, I guess, if you're thinking generally. And then because we have proofs, that is something that we could also use. So it makes sense that we could have either. Obviously, the idea of having no authorization means that this is very permissive, means anybody can manipulate fields, and then you have different possibilities. So if you could, I suppose, make things impossible to change, a field impossible to change, or say that a signature is going to be needed, or a proof, or a proof or signature. No, okay, yeah, one of the two. So that's sorry, let me just check. Okay, some of the questions I'm going to have to come back on, but the question on Slido, thank you for those. These will all get answered, but what I'll do is I'll write out the answers properly and give you some examples, and then put these back into into Discord so you can go through those. So yeah, don't your questions are definitely going to get answered. Okay. There's a link here to, hopefully this is the correct link, to the default, the default permissions that we get as well. And this example here of the unsecure, it's a bit later on. Okay. There's an example here of requiring a signature. Have I got this out of sync? I have a lot. Anyway, and then here we have an example of an unsecure contract where we've set the send permissions to be none for that, which means that kind of is then wide open. So obviously you don't do that, but the default you're going to get is to need a proof for the send. But if you're going to change the permissions, obviously be very careful when you're doing that. Okay. Yeah, so that's what that says there. Okay. Bitwise operations. These may not be things you've come across, but there is support for those. These can be useful, and particularly if it may be useful to represent data in terms of bits, and particularly because that we're limited in the state that we have within our application, and so it may be useful to represent that as bits. It may be more compact, and you may be able to get more into a particular element by doing that. And so if you do that, then you're probably going to need bitwise operations then to manipulate that and make sense of the representation that you've got. And so we have the operations that you'd expect, things like and obviously you can use that to sort of create a mask. So if you have a bit string and you want to mask part of it, and then you can use and to do that. If you want to look at a certain part, you can use ands and nots also for that. And or as well, but again, depending on what you're trying to do. Now the next one here, left shifting, is this is this is the standard idea of bit shifting. So you need to be aware that the bits will get discarded, and then zeros will be padded in as you do this. So this is effectively multiplication, isn't it? So you have the possibility of bits being dropped, but this will return a new field element, and you've got a couple of possibilities depending on the size that you want to be returned. But you can then use a check on this to make sure that what you have is within the correct range. So that you should be using those, and you've got different ones for different types there. Similarly with right shift, and then with right shifts, you will have the possibility of bits are falling off the right being discarded, and again you can check the range with that as well. The other two methods that you have are rotations, which instead of losing bits off either side when you're doing this, they will wrap around. So I don't know if that's I guess it's good in a way that you're not losing you're kind of not losing information, but it's you've got the bits, but they are actually meaning different things. But anyway, that may be useful for your particular application. So you'll have logic around that to make sense of it. Okay. All right. Composability. So this is the idea of us putting together applications, and this was a great feature when DeFi really took off, the idea of composability. The idea being, I think, that you would have some asset, and then you could effectively pass this asset to different applications. So these applications could sort of pass your asset along to the next one. And so at the end of it, you would get the thing that something novel and useful to you, but that would have been built by a kind of a chain of applications working together. So you need so we want to be able to do that, and there's an example as a repo there about that. And what this is doing, we've got a couple of contracts here, and what this is doing is that this we've got three contracts. So our caller here is oh, sorry. Sorry, as I move my mouse, it tries to go back. Sorry about that. And I'll scroll through. I'll try to be a little bit more careful in my as I'm using the touchpad. But we have they have the idea of there's a couple of contracts, and we call one for this. I think it's just in the add plus one, which then calls the incrementer to do the actual adding of the one. So it's just to show you how that how that can be done. Very straightforward, but just to mention that. So by doing that, you're also calling the other contracts. Obviously, you need the you've got the address here for that. Okay. All right, so we've got a little bit of time left. So I'll go on to the action and reducer. So this is a huge topic, really, because there's been a lot of discussion about this, and certainly I do welcome what people think about this, and please feel free to put your experience with this in either a chat or in Discord, something like that, because it is something that there's quite a debate in the community about this, and the motivation behind this is quite understandable, and it comes from the fact that because we're doing computation off chain, and we'll have some kind of data structure that is going to be updated, and then we're going to put the summary of that on chain. So, for example, the Merkle tree, similar to what I showed you before. So that is quite a common pattern, and it's a very sensible thing to do. The problem that we may run into is around the fact that we may get multiple updates, and trying to apply those to the state that we have, doing that correctly is not straightforward, and this is exacerbated, I suppose, because of the block time that we have with Mina is quite large. So it's quite likely that there will be, within, say, a particular block, we could have multiple updates to our data structure that we need to handle. So obviously what we want is to have a consistent view of our state. We don't, we want it to be up to date, and we want it to be correct, but we don't want to run into the sort of typical concurrency problems, such as maybe updates failing because they're updating a stale state or something like that. You need to be careful of that. You also want to make sure that you can, continually update your state, and that the subsequent updates are not going to fail, etc. So this is the motivation. This is why we want to have actions and reducer. We want to be able to apply the changes to our state and do that in a controlled way. I've linked here to a quite a theoretical talk about this or a blog post about this. If you're interested in sort of delving into it deeply, then that's quite a good thing to have a look at. What is interesting is that the way that they it suggests that we can or the approach we can take is to this decoupling of the so we get an intention to change state, and then we have the actual state change itself, and we sort of we make sure we can handle those, or we have those separately. And this is the idea that the intention to change the state then is the action, but the state change itself is then the responsibility of the reducer. So what you could do is, or the idea could be then that you have a number of pending actions that are going to change the state that you have, which is showing the your intentions, or the intentions of the people using your application. And then at a later point, you sort of roll these up, you use a reducer to apply those, and only by doing that as a sort of a batch do you then update the state on chain. So you'd use the reducer to sort of, you know, bring all these changes together and then apply that in one update. Okay. So there's some code example here of what it. Oh, I'm sorry. I don't know why I'm having such problems today with my my touchpad's being too sensitive. Okay. We've only got a couple more pages anyway. So yeah, but the idea is that so the first part of the code is getting your actions, and then from that you have a reducer that is going to take those actions, and from that create one change which we can apply to our state. And yeah, so that's what that bit of code does. There are different possibilities. You've got, this is get actions. So one of them, now this is where we start to get into some of the problems I think that we've had, is the idea that because of the way the Mina blockchain works, we are working with archive nodes as well, which are there to have the complete state. So these may be, you're going to need these to maybe get all the actions. Also, this point I say here, because these things are not stored in the ledger itself, they're existing only on the transaction. So this makes it more difficult to get the correct set of actions that we may want to apply. And overall, I think the experience that people have had, and I am do welcome what people would want to, the experience that people have had on this, is that this doesn't scale particularly well. For example, you do get, if you've got the idea of there being you know, multiple actions that you're going to need to get, then you need to have a reducer running sort of continually to be able to then take those and reduce them. So there's a kind of, I don't know if that's a synchronicity problem, or that gives an actual, you know, an additional requirement that feels slightly awkward. It doesn't fit too well, I guess. And also there are people have found that when they're trying to do this, they come across problems as well. They get errors often because of the size limit of circuits. This could often be problematic, and I think that's understandable. If you think the things that people are often trying to do is to update Merkle trees, which means are doing a lot of hashes altogether to update the root. So if you're doing, if you're taking a lot of updates and and pulling those together, that's a lot of hashes that you're going to need to do, and so you're likely to run into some of the limitations there. So that's really just, I just wanted to introduce that and say that's generally how they work. There's lots of discussion about this at the moment. There's a link there to the an issue. Let me just show you. Yeah, so there's a very good discussion here in when the people are talking about how to solve or the design generally, and there's a good discussion about that, and saying some possibilities and maybe the way forward. There's also this one, I think is, this is a discussion on Discord. Okay, it's not going to open. Okay, it does. But yeah, so discussion quite recently as well around the whole topic and what can we do to overcome some of the difficulties that people have found. And some of the ideas that people have had is to use recursion. So recursion can be useful because it sort of breaks up what you're doing into some chunks that then if you've broken something into chunks, then there's less kind of overhead that is needed if you're trying to do everything together. So if you do things in chunks and then sort of pull those chunks together, there may be less memory requirements, etc., than if you're trying to do it all in one single process. So there's the idea of doing a recursive proof to do that. And again, because Mina is all about recursion, we've got a lot of experience around recursion. We can do recursion within our programs, so that may be a way ahead as well. The other another idea that has been suggested is to try to break out the actions according to the amount of state that is involved, I think. And so you could have if the reducer could be aware of the amount that is involved and then ignore part of that. So people are working at this, trying to get around some of the practical limitations that have come from the action reducer pattern or design. But then also there are alternatives, and I think people have sort of thought that, well, maybe we can do something quite radically different. And what we're going to be talking about, certainly ProtoKit, let me just check that link. We're going to be so we're going to be talking about this much more in the upcoming sessions anyway. But their ideas, as you can see, they're all about developing these application chains. So their ideas for that help with this and help with all of the practicalities of handling storage and the off-chain storage and how to update that, which is kind of where these problems came from. But as I say, I'll be please do let me know your thoughts on this, and I can bring them together. We can go into more details about this, and maybe if you're having problems, we can provide you with some more alternatives as well. But there's some links there to other options as well you can have a look at. Okay, I am out of time, so I'm going to stop sharing there and hand back. And if is Will there?
I'm here.
Oh, yes, it's there. Okay, so I'll hand back to you. And yeah, thanks everyone. If you have comments, please do put them into Discord or Slido, and I'll integrate all of those and then post results back onto Discord. Okay, thanks everyone, and I'll see you at the next session. Thank you.
Yeah, thanks everyone, and big shout out to you, Lawrence, for making this happen.
Pleasure. Thank you.
Bye bye all. Bye bye.